In this EPPIC tutorial video, we will cover how to set up boundary conditions. We will use an example file to show some of the boundary conditions set. Different types of boundary conditions may be needed for different physical problems. Correct setup of these is critical to achieving correct solutions and should be thoroughly checked before running your simulation. Every cell in the simulation must either have a prescribed boundary condition or receive values by interpolation. To define a boundary condition, select the required zone by clicking on it in the main panel, or in its name in the Simulation Items panel. Click on the Define Boundary Condition icon. From the drop-down menu, select the boundary condition needed. When assigned, the Options menu for the boundary condition will appear on the right-hand side of the screen. Each type has options, which can be managed from this panel. Define flow conditions at the boundary by editing the flow condition fields. To quickly duplicate boundary conditions for a given zone, click the Duplicate button. Far-field boundary types should be set according to flow conditions. Symmetry conditions can be defined on boundaries that lie on symmetry planes. They are used to reduce computational effort in problems. To use symmetry boundary conditions, flow field and geometry must be symmetric, meaning zero normal gradients of all variables at symmetry planes. For example, normal velocity at symmetry planes must be zero. Special care must be taken to correctly choose the plane of symmetry. Wall boundary conditions are used to bound solid and fluid regions. In viscous flow, wall subtype should be set to no slip, equating tangential fluid velocity to wall velocity. In non-viscous flow, walls should be set to impermeable, equating velocity normal to the wall to zero. In this example, the wing wall boundary was set to impermeable. The face was chosen as the surface of the wing, in this case K-min. I and J were selected to form around the entire wing, as shown. O-mesh and E-mesh boundary conditions are automatically assigned by EPPIC, depending on the topology of the mesh. In this example, the trailing edge of the wing forms the grid's plane of collapse. Let's create a surface to see what this means. As we can see on the trailing side of the wing, the mesh faces join. Collapsed edges such as these use the E-mesh boundary condition. We can see similar occurrence happening past the extent of the wingtip. O-mesh boundary condition types are used for faces that lie on periodic block connections.